Now we are going to start our discussion on measurement of pressure with the help of manometry. What is manometry? Whenever we go in our lab to conduct the fluid mechanics experiment, we come across with some kind of manometric tubes. It may be simple piezometric tube, it may be U tube, it may be differential pressure manometric device. So what is manometry? Manometry is a standard technique for measuring pressure using liquid columns in vertical or inclined tubes. In this manometry we have tubes which are closed at one end, or these are connected at two ends of the pressure measuring devices. So both ends of the tube is connected to 2 points, and this manometer, which is filled with another fluid, will measure the difference in pressure, or it may be one tube inclined or perpendicular, and one end of the tube is connected to the point where we want to measure the pressure, and another end of the tube may be open to atmosphere. So depending on the shape and their connectivity, we divide the manometer into three categories: piezometric tube, U tube manometer, inclined tube manometer. The fundamental equation of manometry is P is equal to gamma into H plus P naught. Pressure can be written in terms of weight density of fluid multiplied by height of fluid plus P naught, where P naught is atmospheric pressure if this tube is open to atmosphere. So this is a simple piezometric tube in which we have a container A, and this tube is connected to this container. If we want to measure the pressure available in this container, in that case, if we have a valve here, suppose, and if this valve is initially closed, and if we open this valve, in that case this fluid will rise, and this rise of the fluid is function of the pressure available in this container, right. So it means that rise of the fluid in this container is function of the pressure. So we have already studied that pressure is function of H, dP over dz is equal to minus gamma, and for incompressible fluid, if you integrate, then we will get P is equal to gamma into H, right. So how do we get the pressure at point A? The pressure at point A is converted into height of the column. Now how can we relate this height to this pressure available in the container? So for that, what we do, either we draw a horizontal line. When we draw a horizontal line which is connecting the same fluid, means whatever fluid is here, that same fluid is here. So according to this dP over dx is equal to 0, means pressure does not vary in x direction and y direction, or we can say that pressure does not vary along the horizontal plane. Then pressure at point A and pressure at this point will be same, right. Pressure at this point is same as PA. So here pressure is PA, and as we go upward, then pressure reduces, because dP over dz is equal to minus gamma. So as we go upward, pressure reduces, and at this point what is the pressure? Since it is open to atmosphere, so pressure is equal to P naught. So we can write the formula based on this simple principle, that PA absolute is equal to this one. As we go upward, so minus, because as we go upward pressure reduces, so minus gamma 1 H1. What is the pressure exerted by column of the fluid of height H1? That pressure exerted by this column of the fluid is equal to gamma H1. So if we move from this point to this point, then pressure reduces, and what is the reduction? Reduction in the pressure is equal to gamma H1. So P absolute at point A minus gamma 1 H1 is equal to what? Is equal to pressure at this point, and what is the pressure at this point? Is equal to P naught. So is equal to P naught. So with the help of this equation, we have related this absolute pressure to this height of the fluid. This height of the fluid can be measured with the help of some suitable scale depending on the nature of accuracy. And if gamma of the fluid is known to us, and if we measure the absolute pressure with reference to P naught, then this pressure will become gauge pressure, and we may write P A minus P naught gauge pressure is equal to gamma 1 H1. So, pressure can be measured in terms of the height of the fluid, and height of the fluid we can get in this manner by connecting a tube to the container, right. And this height we have to keep this thing in mind, that this is measured in perpendicular direction. If gamma is known to us, H1 can be measured, we can find out the pressure. So, with the help of this simple principle, we can convert pressure into height of a suitable column, and if we measure the height of that suitable column, we can find out the pressure if we know the density of the fluid. Now, only problem with this simple piezometric tube is that if pressure is large, then the length of the tube in perpendicular direction will become very large. So, it will become little uncomfortable. So, what is the solution?